In this model, we have a network example where we've already entered the outflows, inflows, and net flows in the model. And then we've actually entered the total cost functions for shipping cost, production cost, and total cost. Right now, we've got just a trial value or a starting value in the flow or the units shipped of 200 on each route in the network. So the goal now is to go ahead and calculate the required net flows at each wholesaler and then solve the model. So we need an assumption for the percentage of demand that's satisfied at each wholesaler. And in this case, there are 10 wholesalers. So we're just going to assume that each wholesaler satisfies demand of 10%. And so that means that we'll multiply the order quantity times this 10% assumption for each wholesaler. In order to get the demand at each wholesaler that we want to satisfy. And you'll run into other problems where these may not be exactly split equally. Now we can make the assumption that the safety stock would also be divided in the same proportion as the demand, unless we have reason to make some other assumption. And so the safety stock, we'll just multiply it by the 10% as well. Okay. Now, the current inventory would be an assumption in the model, and so that would have to be provided by the wholesaler. In this case, I'll just enter, and you can also enter the values that are going to be assumed for this problem. Those would have to be counted by each wholesaler. But these are the values that were assumed in this example. And so if we add up the safety stock and the current inventory, we'll see what adjustment is required to the safety stock. So we want to hold safety stock of 250 and realize this is just slightly different than 246 due to rounding. But there's inventory of 181, and so we need to ship the difference to bring the safety stock up to the level that we want. That means that the required net flows at each wholesaler will be the demand plus the safety stock, but then we'll subtract the current inventory. Okay, so we'll sum these up, and this will be the total required demand at all wholesalers. All right, so now what we need to do is specify the constraints in the model. And so the first constraint in the model is going to be that the units shipped, or the flow on each route, is less than or equal to the route capacity. And that's over here in columns D and E. So let's enter that into Solver. We'll reset this and just start over. Okay, so the objective is going to be the total cost, and we want that to be minimized. And then the changing cells will be the flows. And then we'll go ahead and add the first constraint, which is that the flow on each route is less than or equal to the capacity on that route. Okay, so that should be flow equal to capacity. The column D values less than or equal to the column E values. All right, the second constraint is related to the factories. The net flows at the factories have to be less than or equal to the factory capacity. and those were provided up here. So let's enter that into Solver. The net flows at the factories are less than or equal to the factory capacities. And so we have that constraint. Now there's some different constraints associated with the distributors. The net flows at the distributors have to be less than or equal to the maximum storage capacity at the distributors. And those are provided right here in column M. So we'll enter that one. Net flows at the distributors are less than or equal to the maximums. Net flows at the distributors also have to be greater than or equal to the minimum. And the minimum would come into play if we wanted to hold a certain level of safety stock at the distributor. In this case, we don't have a minimum, but we'll go ahead and enter this in Solver so we have some flexibility. We want to add that later. All right, and then the last constraint at the distributor level is that the outflows and inflows are less than or equal to the maximum outflows and inflows. And this is basically a handling constraint. Over here we have the maximum inflows and outflows that the distributor can handle in this period of time due to their equipment or their labor. So this constraint will be that all of these inflows and outflows are less than or equal to all of these outflows and inflows here, the maximums. All right, now, what we need to see now is that the wholesalers have all of their demand satisfied, plus their safety stock adjustment accounted for. So the net flows at the wholesalers should be equal to the required net flows at the wholesalers. Okay, so net flows at the wholesalers should be equal to the required net flows at the wholesalers. There is a scenario where if both multiples are 1, we would want to have this as a greater than or equal to constraint, just in case there were a rounding issue here in this model. Okay, and then the last constraint that we need to consider is just an overall balancing constraint. And we notice here that the factory should be producing an amount equivalent to the order quantity times the distributor order multiple times the factory order multiple. That is the factory's production quantity. But then they're also going to produce in order to satisfy any additional safety stock that's needed. So that would be the safety stock minus the current inventory. So this is the required production level for the factory. And so we'll enter that as a constraint in Solver. So total net flows for the factories is equal to the required net flows. Noting that this is equal to ND times NF times Q plus the safety stock adjustment. So we'll enter that into Solver. This required total production or net flow is equal to the required. So this should be all of our constraints. And if we solve the model, we get a total cost of $30,632 in this case. And the shipping plan is contained here in column D.